Hello, dear friends, subscribers, and fans, people of goodwill. Welcome to today's lesson. In this video, we are going to break down computer protocols in a simple and beginner-friendly way. You have probably heard terms like TCP/IP, UDP, HTTPS, TP, and DNS. But what do they actually mean? These are some of the protocols we are going to discuss in this lesson. Therefore, by the end of this lesson, you will understand how devices communicate on the internet and why these protocols are so important in networking, cybersecurity, and everyday technology. What is data? That is the question. Whenever we send data across the internet or over network, a protocol is used specifically for that data and the way in which it is being transmitted, making it that data is considered the raw material of the digital world, often called new oil due to its value. So we are going to break down what data is all about and the types of data. First of all, let's talk about the types of data. Things like qualitative data and quantitative data. Qualitative data, things like non-numerical, like text, audio, images, and video. Then quantitative data are numericals, measurable data, though they are further divided into structure and unstructured. The structure is something that is counted, something that you can measure. That's the type of the quantitative that represents structure. Then unstructured, things that can be organized in rows, columns. Example, email, social media post, tag, label. So how data is used is another way. Information transformation. How is data regarded or being transformed as an information? When data is organized, interpreted, and given context, it becomes information. That is what it is. Now, since we have heard about data and we talk about data being raw material, let me break it down. It is raw material in the sense that when a raw material is gathered and being processed, it becomes a finished product. The same way data is. Data are raw materials gathered, things gathered from outside. You may be under the process of interview. Your details are gathered, put into the system. Your system that are gathered was from outside. Questions were asked. When they were outside, they cannot be transmitted, cannot be sent across through a system until they are put into the devices, into the system. That is when they have formed like an information that can be sent from one device to another, that they can be sent across the internet or over the network. That makes it data and information because they were gathered. They can be unmeasured. They can be in numbers. They can be in alphabet. They can be anything recorded, gathered from outside. But the moment they are into the system, they turn to be an information. That is how data is. Then, when they are information, what makes it possible for them to be transmitted or to go across the internet or over the internet is what we are going to see in this video, which is called the protocols. The protocols is whenever we send data across the internet or over a network, a protocol is used specifically for that information or data and the way in which this information or data is being transmitted. Now, a protocol is just a set of rules that computers follow to communicate or define how devices are supposed to communicate with each other. This happens between them. This happens between the devices. They have a particular rule. They have a particular system. They have a particular way that they listen to each other. This is like a language. When people speak the same language, they understand themselves. Now, when computers use protocols, use the same rule, they communicate with each other. That is why I say think of a language. Both sides must understand the same rule for them to communicate or for their communication to work. Devices must have a rule, the same rule. Computers will have the same rule for them to communicate with each other. That is when protocol comes to play. Protocols are a set of rules that devices use in order to communicate. Now that we understand what protocol stands for, we are going to know why these protocols are very important and why they matters. Let us break it in a simple way that we have to understand again and again what protocol stands for. Protocols are not human beings, may not be physical, no. They are rules. Let us talk about in real life. We have organizations, we have societies that go by a rule. They have rules that they abide on, that guide the association, that they do things. The same thing is applicable to devices. Your device, my own device, and every other device have the way they play their things, have the way they transmit data, the information, the message. They have the way the computer A can send message, can send email, can send a file to computer B. They have their protocol, their law, their rule that A will say, this is the rule. This is where I receive and how I am going to receive your file. B says, this is how I receive or I will send it. These are rules. And that rules involve what we call ports. Ports, P-O-R-T, or you can put it S when they are because there are many anyway. These are door, like a door to your device, like a door that welcomes your file. Your file is in transit, being sent, following the rules of this is how I'm going to receive it. but they have to come to you through a port. And that port will have a number for that particular port. And that port bears the name of that thing it is sending for. That is how they communicate. The A will receive your message through this so port number. The B will send the message through this port so number. That is how it is done. The IP address is the room. The port is the door. And that port, or each port that leads to door, has a number, a service number. Is it in a real life like a hotel? It has a number. You want to locate your friend that is staying somewhere, he will give you a port. He will give you a number of his room. You can only get your friend and deliver the message you are bringing to him through that particular port. If you don't have the number of that door, how can you enter the door? The door bears a number. And the door in this context here is the port. Let's take, for example, maybe some of you don't know what port is. We have so many ports, 1,000 and under devices. The first port I'm going to use here as an example is USB port. All of us know where you can plug your USB in your device, in your laptop, in your desktop, some ports in your phone. These are what is called ports, where you can plug in some of your hardware. Your keyboard is plugged into a port. It's through that port that the keyboard transmits its signals, its message. Your mouse goes into a port. It's through that particular port on your device, on your laptop, that your port can transmit, can send its message, its signals. These are what is called ports, and they have numbers. This is what we are going to study here today. You're going to see any protocol with a number of a port where it exists. As I said before, protocols are not things physical. These are softwares. These are things that goes in internet, network. So the importance of protocols is that to ensure that data is sent and received correctly, to ensure that devices identify each other, they prevent confusion between different types of communication. That is why the protocol matters. As I said earlier, the port. A port is a number that identifies a specific type of network service on a device. Think of your computer like a building. The IP address is the building street address. The port is the door number that tells you which room you want to reach. Each protocol uses a specific port to send and receive traffic through, and you can think of a port like a numbered door on the host device. That is the port. And why does this port matters? Ports allow multiple services to run on one device. Like in one desktop or one computer or one device may have several ports on it. There's a port for USB, there's a port for your mouse, there's a port for your keyboard, all of them working together in that same device at the same time, but working the different things. This is how ports allow multiple services to run. The ports have route data to a correct application. Route, sending, movement of data to a correct applications is by the help of ports. They keep communication organized so that the communication will be organized very well. When they enter from different ports, there will be no confusion. But if it is one particular port, there must be jamming on traffic. There must be one or two things that will cause problems. Each time troubleshooting will be occurring. But because there are multiple ports on the host device, the traffics are being sent, organized. Other network devices such as firewalls, yes, there are ports for some devices such as firewalls that their own job is to block or to reroute traffic. When traffic is too much, when there is appearing to be disturbances in a device, they come in to play. In this lesson, we are going to look at some of the most commonly used ports and protocols you will see in networking. Most commonly ones. You have seen this HTTP. You use this in your URL, in your website, so many times in your browsers. That is why we say we are going to give example how the port and the protocol works together, how these things can work together, more especially you're familiar with this. So when you visit a website, for example, your browser uses HTTPS or HTTP protocols. These protocols, it connects to the server's IP address. Servers are involved and their IP address. This protocol now will connect to the address in your server. That your server probably is using, the port it uses there is, it uses port 80 for HTTP or uses port 443 on HTTPS. Then what will the server do? The server respond using the same protocol. Your server will use the same protocol. That is its response. The same protocol your browser was using on your device. This combination ensures the right rules are used. The data goes to the right service. That is what that signifies. That the right protocol is used and the data, your message, has gone to the right service because two of them bear the same port, but they are different devices. This is how this plays. Now, these are the type of protocols. Here you can see them with names. They have names. But these are protocols. These are the rules we are talking about. SSH is a rule. Then the port from where this gets to you sends his message to the other person is through port number 22. That is the door. Where that USB, where that mouse, where that particular SSH, which is a log, where it is, the port where it goes in to your device to deliver the message, to deliver the email to your own device. This protocol, which is called Secure Share, SSH, allows two devices to communicate. That is the rule there, with each other, securely, through encryption, through a key, through a lock, that nothing can disrupt that message except through its transit, except it goes to the right until the right enters into the right place it's supposed to be. That is what encryption means. Trying to transform the message when the message is on transit. That is, it will be unreadable. That is when we talk about secure, we talk about encryption, we talk about changing the system until your message gets to you. So while it can transfer files, we typically use secure share. We use it to secure login or remote network device in the system. We use it to use what? To secure your login or when you remote network devices. That is where all this one play. We have the second one on our list, Telnet. Telnet is a protocol. It's another protocol, not a rule. I told you it's not something physical, but these are rules. The rules that hold the devices together, that makes them to hear one language, that makes them to work along with each other. This second rule is called Telnet because it must have a name. It's another protocol that allows us to remotely connect to one another on the same network. Telnet uses port 23. That is the port you use. That is the door it will pass through to get into your system to do the job. The problem is that the protocol doesn't utilize any encryption. This particular protocol does not utilize any encryption. So it is really being replaced by Secure Shell. Because it doesn't use encryption, it is replaced by Secure Shell that uses encryption. But we need to be aware of it and how we may see it used. The next is Remote Desktop Protocol. That is another protocol. Another common remote protocol is Microsoft Remote Desktop Protocol, which is RODP. RODP is a proprietary Microsoft protocol. Proprietary, free to be used. It runs on the port 3389. That is the port through this protocol runs in. Remote Desktop Protocol allows us, that is what it does. It allows us to actually send the remote computer's display and use our local input devices, such as mouse, the keyboard, to perform tasks from our own machine. This protocol is extremely helpful when you are troubleshooting devices, issues from across the network. Another one we are going to talk about is NetBIOS. What is NetBIOS protocol? On most networks, Network Basic Input-Output System, or NetBIOS, is used to share files and communicate locally. As network becomes more sophisticated, NetBIOS was combined with TCP so that it could be routed. NetBIOS with TCP is known as NetBET, but we still refer it as NetBIOS. It uses port 139 to establish a connection. By now, you must have known what a port is and what a protocol is. This is why when we mention the type of protocol, we explain the role that particular protocol plays between two computers and port 134. That is what this NetBIOS used to transfer any information back and forth during the session. NetBIOS requires each computer to have a unique NetBIOS computer name, so there is no confusion. This is especially important on a Microsoft network. Now, we are going to talk about server message block, SMB. What is server message block protocol and what does it do? Server message block SMB protocol is typically used to share and transfer data. When you're sharing your data and transferring your data, what you are using is this law, this rule, server message block. That is what the user is using on that device, is this particular rule that says server message block and the TCP to transfer data through port 445, which makes it very reliable. This is the port number through which the server message block transfers message. Microsoft uses this particular protocol, this particular rule, to implement the common internet file system, CIF. It uses it to share files across Windows-based network. That is what Microsoft uses. Server message block to share its file. It uses this rule. And this rule is applied on the port 445 on your device. That is where this rule goes in to perform its duty. Now you're getting it. I hope you're getting it right. How and what protocols are, what they stand for, how they act. We are going to look into another protocol. That is what we are going to look. Another protocol on our list is DNS, Domain Name Service or System. Domain Name System. What does this stand for? Let's take a look at some of the common networking protocols now. First is the Domain Name Service, DNS, which runs on port 53. It runs on port 53. Domain Name Service, what it does, it is responsible for matching the host names to their IP addresses. That is what this rule does. It makes them to match that name to their host name with the address, IP address, and vice versa. That is what this domain name system protocol rule makes it happen. So, for example, when you type www. For example, testout.com into your web browser, this rule, domain name system server, because each protocol's name or rule has a server that connects to your system. So this server is now responsible for translating that into the network, into the www.testwork that you type in. The web server corresponding IP address. It will make it, they will connect to each other. Now, the next protocol on our list is Dynamic Host Configuration Protocol, or DHCP. This protocol is used to assign network devices their IP address configuration when they connect into a network. Example, when a client connects the DHCP request is sent on port 67 to the DHCP server. which sent the IP address configuration back to the host using port 68. Now, the SNMP is a simple network management protocol, or SNMP. It uses port 161 and 162. It is used for network management and networking device monitoring. Things like firewalls, switches, printers, they utilize the SNMP. An SNMP manager is typically installed on the server, and an SNMP agent is installed on each host device to gather information about those devices. When the manager needs to talk to the agent, port 161 is used. And when the agent sends an alert to the manager, it happens from port 162. The next on our list is LDAP, which is Lightweight Directory Access Protocol. This is a store protocol on the network, because our network needs somewhere to be stored. Usernames, password, computer account, and other important users and device information. That is why this LDAP is necessary. This is all stored in a directory services such as Microsoft Active Directory. The Lightweight Directory Access Protocol, LDAP, is what accesses this information with port 389. LDAP is an open source, vendor neutral protocol, so it can work either other directory services, not just Active Directory. The last two protocols are the ones you probably use the most: Hypertext Transfer Protocol, HTTP, and Hypertext Transfer Protocol Secure, HTTPS. They are what we use to transfer hypermedia. So the most common use of these protocols is to transfer web pages across the internet with hyperlink. HTTP uses port 80 and has no encryption, so it is very unsecure. HTTPS does the same thing, but it uses port 443 and encrypts all communication with TLS. Summary. That is it for today. In this lesson, we looked at many of the most common ports and protocols you will come across. For example, there are remote connections, protocols like RDP, email protocols like IMAP and SMTP, and networking protocol like DHCP or LDAP. It is extremely important to know and understand each of them quite well, as they are fundamental to getting to the bottom of any network connection issues you will run into. The last is how we appreciate all of you. And today, we did not just learn about protocols and ports, we unlocked the language that computers use to communicate today. You learn how devices talk, how data travel, and how networks stay organized. Understanding this fundamental or this foundation puts you in control of the network, not the other way around. Keep practicing and let this be the start of your deeper journey into networking. Keep exploring, keep questioning, and keep building your confidence. The more you understand the flow of data, the more powerful you become in the world of IT. Thank you for listening to us. Subscribe to our channel and click to a subscribe button. Thank you and be blessed.